All right, we are moving on to lesson 4.5, dilation. So I'm going to present my screen so we can get started. Okay, so dilations. This is going to be a little bit different than our previous transformations because this one does not preserve the distance, okay? Angle measures are preserved, but distance is not, which means our shapes are going to change size, all right? So a dilation is a transformation which a figure enlarges or reduces with respect to a fixed point C called the center of dilation and a scale factor K, which is the ratio of lengths of the corresponding sides of an image and pre-image. All right, so a few important things that I just read there that you might want to jot down or highlight, take note of. So one thing, ignore that. One thing is that your scale factor, if we're asked to find the scale factor, we're always going to write it as image over pre-image. So we're going to pick like two corresponding side lengths and write the image length over the pre-image length and then simplify that ratio, okay? So if P is the center, if P is the center point, if P is the center point C, then P equals P prime. Oh, okay, sorry. So the dilation, come back up here, I didn't read this part. A dilation with a center of dilation C and a scale factor K maps every point P in a figure to P prime. So I needed to read that to understand this. So C is the center of dilation and point P is what we're dilating. So if you have your center, your point P is either going to get closer to the center of dilation or point P is going to move further away from the center of dilation, okay? And as I'm using this word dilation, hopefully you guys are kind of thinking about other things that you know about dilation, such as when you go to the eye doctor and they dilate your pupils. Your pupils could get super, super teeny or really, really large, depending on what the eye doctor needs to do and look at in your eye. All right, so it's kind of similar to that. If P is not the center point C, then the image P prime lies on CP. The scale factor K is a positive number such that CP prime divide or over CP. That's actually what I explained over here. Your scale factor is going to equal the side length of one of the side lengths of your image over the corresponding side length of your pre-image, okay? And then the angle measures are preserved, so angles don't change, all right? So let's keep on moving along. All right, so find the scale factor of dilation, then tell whether the dilation is a reduction or an enlargement, all right? So here you have P and here you have P prime. So you know that this safety pin is your pre-image and this safety pin is your image, okay? So just looking, you can make the determination whether it's a reduction or an enlargement. This would be an enlargement. I'll get my pen out. All right, so for letter A, it's an enlargement. Now to figure out your scale factor, it's always image over pre-image. All right. For this, we're not taking the side length of one of the sides of the paper or safety pin, which sometimes we'll do, but this time we're taking the distance from the center of dilation to the image. That distance is 8. Oh, sorry. That's not my image. The distance from the center to the image, the P prime, excuse me, is my image. So that's 12. And the pre-image, the original, the distance from the center to the pre-image is 8. And we'll simplify our scale factor to get 3 over 2. So your scale factor is 3 over 2, and it is an enlargement. For the next one, the center of dilation is C, all right? P is my pre-image, and P prime is my image. So is it getting smaller or larger? Is it getting closer or further away to the center of dilation? The the paperclip, couldn't think of what it was called, is moving closer to the center of dilation and it's getting smaller. So this is a reduction. We still find the scale factor the same way. Reduction or enlargement doesn't matter. It's always going to be image over pre-image. So what is the distance from the center of dilation to the image? All right, that's going to be 18. And then the pre-image from the center to the pre-image is your 30. And you'll simplify that to 3/5. Okay. All right, so notice, think about the value of this scale factor and the fact that it's an enlargement. Think about the value of this scale factor and the fact that it's a reduction. And just keep that in mind as we continue to move along. All right? Okay. Coordinate rule for dilations. If P, X, comma, Y is the pre-image of a point, then its image after a dilation centered at the origin, 0, 0, with scale factor K, is the point P prime, which is K times X, K times Y. All that means is when you are trying to find where a new image is going to be, you just have to multiply the coordinates by your scale factor. And we're going to demonstrate that right now. Super easy. Okay, so you're given point A, you're given point B, you're given point C. A is 2, 1, B is 4, 1, and C is 4, -1. We want to know where is A prime, B prime, and C prime after a dilation with a scale factor of 2. Well, first off, if there's a scale factor of 2, do you think this is going to be an enlargement or reduction? Do you think our triangle is going to get larger or smaller? Is a triangle going to move further away from the origin, the center of dilation, or closer towards? Right, think about those questions, and then we'll graph it and see if you are correct. All right, to figure out what the coordinates of your new point is, you just have to multiply everything by 2. So I'll write out the first one. It's 2 times 2 and 1 times 2. So the new coordinate is 4, 2. B is going to be 2 times 4 and 1 times 2. So it's going to have a coordinate of 8, 2. And then I'm going to have 2 times 4 and 2 times -1. And that's going to give you a coordinate of 8, -2. So let's plot A, 2, 1. Here's A. B is 4, 1. C is 4, -1. So A, B, and C. All right, and then A prime is 4, 2. B prime is 8, 2. And C prime is 8, -2. So did your triangle enlarge or reduce in size? It enlarged. Did the triangle get closer to or further away from the origin, the center of dilation? Further away. So again, think about that scale factor. It was a scale factor of 2. It got larger and further away from the center of dilation. Okay. All right, let's keep on moving along. Okay, using a negative scale factor. So using a negative scale factor doesn't really change anything that we're going to do. All right, we'll talk about what it looks like. But as far as the process is concerned, still the same. So I'm going to list my coordinates of F, G, and H. We have a triangle again that we're going to dilate. So F, G, H, -4, -2, -2, 4, -2, -2, F prime, G prime, H prime. Scale factor is -1/2. So just like I did for the last problem, I have to multiply all of these coordinates by -1/2. So I'll write the first one out and then I'm just going to do the rest in my head. 4 times, sorry, let's give myself more room. It's not going to work out very well. Try this again. Scale factor is -2. So -4 times -1/2 and -2 times -1/2. So that's going to give you a coordinate of 2, 1. All right. Multiply this by -1/2. That's going to be a 1. Multiply this value by -1/2. That's -2. Multiply by -1/2. That's a 1. Multiply by -1/2. That's a 1. All right. So plotting the points, F prime is at 2, 1. Oh, I didn't even do the original. I'll have to go back. 1, -2. It's G prime. And 1, 1. H prime. All right, so here is, whoop, that was terrible. All right, I'm not going to erase. Just imagine that straight. All right, so that's my image. My pre-image was -4, -2. That's F. -2, 4. That's G. And -2, -2. That is H. Okay, so that's not straight at all, but so what do you notice? This is my original, my pre-image, this is my image. The triangle got smaller and closer to the center of dilation. So hopefully you're noticing that when you have scale factors that are fractional small numbers, numbers between 0 and 1, and I'm talking about the absolute value of the number, don't worry about the fact that it's negative, but if you have fractional scale factors, the absolute value of your scale factor, if it's a number between 0 and 1, a fraction, small little fraction, it's going to be a reduction, and your image is going to get closer to the center of dilation. If your scale factor, the absolute value of your scale factor, is a number greater than 1, then it's going to be an enlargement and it's going to move away from the center. Now, what about the negative? Because I said don't worry about negative, just the absolute value. Well, what happened when we had a negative scale factor? Look at the diagram, and I know I drew terrible triangles, but look at the diagram. What do you think happened? There's a reflection. It flips, all right? So when you have a scale factor that's negative, there is a reflection. And again, you don't really have to worry about the fact that it's a reflection because we still do the same process of just multiplying each of the X and Y coordinates by the given scale factor to figure out the location of our new image. All right, let's keep on moving along. Finding the scale factor. You're making your own photo stickers. Your photo is 4 inches by 4 inches. The image on the stickers is 1.1 inches by 1.1 inches. What is the scale factor of this dilation? Okay, so remember the way we find scale factor. The way we find scale factor is always the same. Scale factor is your image over pre-image. Okay, so one of the side lengths of your image, the new sticker, right, is 1.1. And that is being compared to, that corresponds to this side length of your pre-image, which is 4 units long. Now we have to simplify that. So move the decimal one place in each number. So that's 11 over 40. And that can't be simplified any further, so that is your scale factor. All right, it's not proper to leave decimals in our fractions, so that's why this was not completely simplified. Multiply top and bottom by 10, or move the decimal one place on top and bottom. That's where 11 over 40 came from. And there you go. All right. I think this next example is actually the same as the one above. Let me see real fast. Yeah, that one's a typo. I think that's all I wanted to do, guys. Let me just take a quick peek, make sure I hit all the problems I wanted to do. Yeah, that is it for this lesson. I already have that up. So I will see you back here for the next one. Bye.